distributive property, what you were looking at right now. Objective 28, distributive property, one of the most important concepts that you need to understand. You really need to have this thing mastered for one reason. If I say, hey, you should distribute that, you need to know exactly what I'm talking about.
Yes, sir.
Also, what we're going to do is objective 29, which is called combine like terms.
We're doing this because we didn't do anything else.
Objective 29 is equally important. These are very similar. They go hand in hand. And now, not only Algebra 1 is it important. When you get into geometry, it's important. When you're in Algebra 2, it's important. If you go into math beyond Algebra 2, this skill will never go away. You need to be able to do it. So when I put in the notes that it is very important, yeah, it's very important. In order to be successful in algebra, this concept has to be automatic. Oh, we've talked about expressions this week. What is an expression? Does not have an equal sign. There's pluses and minuses in it. It's a collection of algebra terms, collection of pieces. It looks like a bunch of algebra junk, and it doesn't have an equal sign on it. When an expression or part of an expression is surrounded by parentheses, often what we need to do is distribute it. We're going to have a number to the left now. Looking at this right here. Say I block the 6 off, just as outside. For some reason, they've taken an expression and they put it in a parenthesis. How do I know that that thing is an expression? There's no equal sign. It looks like a couple of pieces. How many terms are inside that parenthesis? 2. How do we know? Yeah. They're separated by this 1 plus sign. So basically, this inside the parenthesis is an expression with 2 pieces. A lot of times what you'll see is they put that parenthesis and then they put a 6 outside of it. This is when we're going to need to distribute. And what distributing means is we are going to multiply this 6 by both pieces inside. You'll say 6 times this one and 6 times that one. And at first, and even as you get into Algebra 2 and beyond, sometimes it still helps to draw those arrows to remind yourself what we're doing. So when we say 6 times 2x, yeah, 6 times 2 is what? 6 times 2 is 12. Since one of them is an x piece, now it's 12x. And then we go 6 times 1, and what's 6 times 1? 6. And we get 6. All right, look on the back side. Here's a few of them that we want to try, and then I'm going to have you try some on your own, and I want to come and monitor and make sure that you know how to do it. Here's an expression inside of a parenthesis with an 8 next to it. If I saw that on your work, I would say, hey, you need to distribute that. So go 8 times 3x with an arrow. What is 8 times 3x, by the way? 24x. 8 times 3 is 24, and then there's an x. Then what is 8 times 2? 16. But it's positive 16. It's positive 8, and it's positive 2, so we go positive 16. Now, everything we've done so far has had a bunch of plus signs. What if we had a minus sign inside? Here's how we treat it. At first, it's just 4 times 2x, just like before. What's 4 times 2? 8 with an x. Now when you multiply this 4 and this 3, it's not 3. It's actually negative 3. So what is 4 times negative 3?
Negative 12.
Negative 12. Don't need that arrow. It's just 8x minus 12. Okay, I've got 2 for you to try. It shouldn't take but 30 seconds to do both of these. Notice that one of them is just a plus sign. Everything's positive, and one of them has a minus sign. See if we can do both of them. Distribute, draw the arrows, see if you can do them both in about 30 seconds. 2 times 3x plus 2, and 3 times 4x minus 1. Okay. On the first one, if I drew the arrows, they would go, okay, 2 times 3x is what?
6x.
And then 2 times 2 is positive 4, so plus 4. On this other one, 3 and 4,
12x.
12x. Now this time, it's not 3 times 1. It's 3 times negative 1. So what is it?
Negative 3.
Negative 3. A freshman mistake that I'm going to see a lot of is that somebody will give this answer as 12x plus 3. Because they say, look, there's 12x. And then their eyes skip over this and say, there's 3. And they put 12x plus 3. And I guarantee you, if you had a multiple choice answer, 12x plus 3 would be one of the options. So be very careful when you see this. It is positive 3, and this is negative 1. All right, sometimes the number outside, so far they've always been positive. They've been 6 and 8 and 2 and 3. Sometimes the number outside is negative. When the number outside is negative, you treat this as not 4, this is negative 4. And you will distribute a negative 4. So this is negative 4 times 6. What is that?
Negative 24.
Negative 24x. And now it's negative 4 times 2.
Negative 6.
Negative 8. Saying negative 6, that's a common mistake. We've got to go, okay, negative 4 times 2 is negative 8. Negative 4 minus 2. Okay, negative 2 and 7 makes
Negative 14x.
14x. Now here you're going to multiply two negatives. Negative 2 times negative 4.
Positive.
Plus 8.
So plus 8.
Plus 8. Negative 2 times negative 4. The only time we say that two negatives make a positive is when you're multiplying two negatives or dividing two negatives. So here we are multiplying two negatives. And the last one, take 15 seconds to do the last one. The last one has minuses all over the place, so take 15 seconds and write it out. All right, you got a negative 8 that you need to distribute. So I would say distribute. If I walk by and you're working on this, my advice would be, hey, distribute the negative 8. What I mean is, what is negative 8 times 6? Negative 48. And this is with an x. Then negative 8 and negative 4.
32.
Negative.
Plus
Positive 24.
Positive.
34. 32. Positive
Oh, yeah,
32.
Oh yeah, wait, why are you telling me the wrong numbers?
Because
Yeah, that's what you're wrong.
It's you put 24.
Because Mandy got.
How about negative 6 times negative 4 is
Yeah,
positive
that's what I was thinking too.
32. Not 6 times 4. Negative 8 times negative 4. Positive 32. Okay, looking at number 29. So there's 28. Distributive property. I'm going to come back and make sure you remember what that means when I say distribute and distributive property. Now, I want you to look at combine like terms. Combining like terms, just like before, the first thing you see up here, just like distributive property, this one is very, 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 very important. This concept you will need to do, not just in here. You're going to have to do it in geometry. You're going to have to do it in algebra too. And if you go on the trig or anything like that, you are definitely going to have to do it. Understanding what terms are, and then how we can put them together. All right, this right here is an expression. How do I know that that is an expression?
There's no equal
Because
sign.
there's no equal sign.
Yeah, I don't see an equal sign. It definitely looks like algebra junk on the board, separated by pluses and minuses. So it's a collection of terms. How many terms in specific are in this expression?
5 terms.
5 terms. Now what combining like terms will do, think of it like this. Imagine that you got a table spread out, and then there's a whole bunch of Legos spilled out on the table. And your job is to kind of put them back together, at least in order. You're going to categorize your Legos. Blues go together, reds go together, whites go together. That's what combining like terms is. These are pieces. one piece. Here's a piece, here's a piece, here's a piece, here's a piece. Just like Legos. Legos are pieces. Here's one, here's one, here's one, here's one, here's one. Some of them are all alike. They're similar, and we're going to put them together. If you look, there's 3 of them, of these pieces, that have no x's on them at all. This one, 3. This one, -1. This one, 6. Think of those like blue Legos. Let's just put all the blue Legos together as if we're just going to pull them out of the expression. 3, -1, and 6. 3, -1, and 6. They could all go together. If you put those 3 things together, look at the 2 pieces that are left. What are they? 2x and 7x. Now, just so that we can communicate together very well, if I asked what type of piece this was, I would say that's an x piece. This is an x piece because it's a number with an x on it, so it's an x piece. Think of those as your red Legos. You could put together your red Legos. So if you put these 3 together, first let's just do that. What is, I'm going to put this one and this one and this one together. What is 3 minus 1? 2. Then add 6 to that. 8. So if you put all those just numbers together, it's 8. That's where we get 8. Let's just put the numbers together and you get 8. Then let's put the red Legos together, which the red Legos are going to be these X's. I got 2 of them, and then over here I got another positive 7 of them. So if you had 2 of them and 7 of them, how many do you have? You have 9 of them. 9 of them. So I had 8 numbers, and I had 9 X's. They would actually probably write it this way. So on your notes, do this. Put or. They're going to put their X pieces together first. So they're going to probably say 9X plus 8. If I combined all my X's, I found out I had 9 of them. I combined all my numbers, I found out I had 8 of them. All right, now let's look at the back side. All right, sometimes it's not just 2 types of pieces. It's not red and blue Legos. Sometimes there's 3 pieces. On this expression, there's X's, there's Y's, and there's numbers. So think of them as X pieces, Y pieces, and number pieces. So when you look at the expression, you just identify each type of piece. A number piece, a Y piece, an X piece, a Y piece, a number piece, an X piece. If I just put my number pieces together, I would have -4 and positive 12. And I would put those together right here. -4 and positive 12. What are my 2 X pieces?
3 and 4.
Now careful, you got it. It's not 3x because what is that?
-3x.
So it's -3x, and this is
-4x.
-4x. So the x pieces is -3x and -4x. And that is this, and this. And then all that's left is the y pieces. Think of those as the white Legos.
6y plus 2y.
6y plus 2y, both positive. 6y plus 2y. Now, when they do your answers, usually what they're going to do is they're going to go in alphabetical order. They'll put the x pieces together, then they'll say the y pieces, and then whatever the numbers are. So if you looked at your x pieces, -3 minus 4.
-7x.
-7. Now, anybody in here is confused and thinks that, hey, 2 negatives make a positive. 2 negatives make a positive only when you're doing what?
Multiplication or division.
Multiplying them or dividing. We're not multiplying or dividing. Combining is really just adding or subtracting. So -3 subtract 4 is -7. So how many x pieces do you have? -7. You put these 2 pieces together, that's these 2 pieces. -7x. All right, your y pieces. I've got 6y and 2y, both positive.
8y.
8y.
Plus y.
Yeah, I'm going to put 8y here. And then I need, because this is a different term, I need a sign right here.
Plus.
I'm going to put a plus because this is a positive 8y. And then I look at my numbers, and I've got -4 and +12.
Negative.
It is again, it's a +8, so I'm going to put a +8. So we had an expression up here. When you started, you had an expression with 6 pieces. But we could pair up all the pieces, and it really ends up simplifying to just 3 pieces. It's just a collection of different Legos, and you organize them, and you end up with just 3 pieces. It's still an expression. It's just a little bit simpler after you combine the like terms. All right, this last piece up here says, we looked at x pieces, y pieces, and number pieces. However, sometimes you'll see something like 6x squared. If you're looking at 6x squared, I would call that an x squared piece. It doesn't go together with other x pieces. So it's its own type. It's like a fancy x. 6x squared and 2x squared. You only put x squareds with other x squareds. X's go with x's. X squareds are fancy, and they go with other x squareds. So when you look at this expression, you have an x squared piece, an x piece, an x squared piece, an x piece. Put your fancy x squareds together first. You got 2 of them and 4 of them. So how many x squareds are there really?
6x squared.
6 of them. Then put all the regular x's together next. 3x and 5x. So how many x's are there?
8.
8x. Okay, here's what we're going to do. 2 examples, just remember, we did distributing and combining like terms today. I need some numbers, and we'll start with, I'm trying to get those numbers, I don't know, don't go anything bigger than 50.
5,
Okay, I start with a 5,
3,
I got one.
30.
I got 3x,
19.
30.
what do you have?
19.
Plus
21,
19y,
29,
plus 21,
10.
minus 29y, or 10, and
45.
29.
that's next. Here it is. That's what you just made.
Yeah, 19.
Okay, this is an expression. Look up here with your eyes and tell me how many pieces are in this ugly looking expression.
1, 2, 3, 4, 5, 6, 7, 8.
Alert, shut up, you don't know anything.
7. Are you seeing 7? We're seeing 7.
7.
Okay, what kind of pieces do you have in this collection?
X, Y, numbers.
X pieces, Y pieces, and what else?
Number pieces.
Number pieces. When it comes to putting them together, put together your X's, then your Y's, and then your numbers. So,
10 and 3.
X piece,
10 and 3.
and there's these are not X pieces.
10.
All right, so we got 3x and 10x. 13x. Okay, then let's put together your y's.
19 and 29.
19 and 21.
Negative 29.
19 and 29.
I got 19 y's. I got negative 29 y's.
Negative 9.
10.
Last thing I've got is numbers.
30. Negative 25. Negative 25.
5,
Not in
negative
PT.
30.
Minus 25.
Okay.
I'll sit.
What it, hey, guys up front. Guys up front. What is 5 minus 30?
Negative 25.
Negative 25. Add 21 back.
Negative
Negative 4. So if you put these 3 together, negative 4. You took 7 Legos and you combined it down into 3 groups. This is the X's, this is the Y's, that's the numbers, and that is combining like terms. Now, distributing. Do not forget, when I say distribute, what's the number outside?
2.
2. First thing is you're going to go 2 times what?
3.
3x.
What is that?
6x.
And now this is not, don't say 2 times 4, it's 2 times what?
Negative 4.
Negative 4.
What was that?
Negative 8.
4. Negative 8.
Negative 8. And there is distributing. The next thing you're going to see when we get back on Monday is that we're going to put combining like terms and distributing together on the same types of problems. But that is it. You can go ahead and get started on whatever you have to work on.